Yeah, g'day, Mark here, and welcome back to my channel. Now this week, I need to finish making up a couple of 25mm boring bars, which go on this beefy Narex boring and facing head. I already roughed them up ages ago. Now this is really part 2 of a video which I started about a year ago, but I had a problem with the Maho, because that video covers most of the design and the machining of the blanks. I'll leave a link up here somewhere, and I'll be finishing off all the milling on the Maho milling machine with them held in my rotary table. Before I can bore anything with it, I need a boring bar. Since I've already covered the design of these boring bars and also making up the blanks and stuff, in this video I'm gonna concentrate on the milling and also... Now before we get started on those boring bars, if you watched last week's video on making the collet adapter for this rotary table, you'd know that I ended up with some run out issues. And there was a lot of good discussion about why this occurred, what I could have done to prevent it, and also maybe some workarounds to live with it. The basic issue is I machined this side, including the taper and the face of it, but then I took the part out, flipped it, mounted it in a 4-jaw chuck, dialed it back in as well as I could, and machined the cylindrical shaft on the back, which locates this in the rotary table. The root cause of the issue was moving the part and cutting those critical features on 2 different setups. At the moment, the first thing I'm going to do is just do a survey and try and work out where the problems lie. If you remember from my last video, this bore is 60mm and it's precision ground from Nikken. This matching shaft, I tried to turn about 3/100th undersize, which would be a G7 shaft fit, and looking that up later, that was a mistake. I probably should have gone for a tighter tolerance band, more like G6, but let's see how much wiggle I get in practice. There's only about 2/100ths of a millimeter play once it's well seated. Right, let's see if we can get a little bit more accuracy out of this collet adapter. The first thing to check is just whether there's any burrs, so get the old precision stones out for that. I already did this when I first got the rotary table, so I don't think there are any burrs left, and sure enough, don't feel any. Okay, let's then take a look at the bore itself, see if it's in good condition. Now admittedly this is not the greatest clock in the world, but gives you an indication. It seems that bore is not the problem. So we'll just start off dropping it in and not bothering doing anything special about the centering. So that was 3/100ths of run out, and this is about the high spot. So let's try moving the adapter just back this way. So high spot, low spot, high spot, low spot. That kind of uncontrolled movement did move the run out from one side to the other. So now I've got to try and loosen this off, put a clock on it and gently tap it and try and halve the movement. Okay, that sure looks like it's about dead nuts. I'm going to start with my 16mm collet because it's one that looks like it's never been abused. Now working on the OD, I've been able to switch out from 1/100th of a millimeter to 10 times the resolution. Where before we were between 10 and 20 microns on this gauge, now it's showing 50 to 60 microns of total indicated run out. One of the things that was pointed out is it could be the anti-rotation pin is projecting in too far and pushing on the side of the collet. So I'll just remove this completely. Glad I only used weak Loctite on it. Right, let's see if I can get this bumped into center better. -5. -10, -5, this is roughly 0. So there's my low spot here. That's within a micron or 2 over the whole range of movement, so let's crank it down there, see if it stays where I put it. So locking it down, Yeah, there's a bit of bounce and stuff, but looking it down, it looks like I'm now within a half a micron. I'll continue my rest of my measurements based on that. I guess that's kind of in line with what I looked at on my last video, where I got about 30 to 40 microns of run out here at the collet. It's obviously not this alignment pin that's causing that amount of run out. So I've already got the rotary table bolted down and dialed in. From there, I can start setting up my cutting tools. Right, that's 0x. I now need to halve that, so at 12.14, I'm on my center line. Here we know that our bar is 12.14 radius. And we know we're on the upper side, so that's now zeroed at the center line. So I'm going to need 6 different tools. A couple I need to change out. Although I've got a second small collet chuck, I've only got one 4mm in the E16 size, so I have to put this in a big chuck. Right, the last one I need to take a look at is my little D-bit. Before I can use this again, I better clean it up a little. So I think I made 2 mistakes when I first ground this. One was having the grinding wheel set up so that it exited the cut on the cutting edge, which tends to cause chip out supposedly, although it doesn't look too bad after that use. So let's flip that over. And the second thing, I think it was simply a 2-course diamond wheel. I think it was 150 micron. I'm not sure. I think this wheel that I've got mounted now is finer than that. The label's gone from it, so I can't really tell. If you look at from the cutting edge down here, I've got a little bit of back clearance. I ground it that way. But as we rotate, it looks like it comes back up at the end here. Maybe there was just no clearance on this rear corner and it was dragging and got knocked off. Could well be the case. So I need to be a little more careful when I grind in the back clearance, that I go a bit further in rotation and make sure I clean up that edge properly. I don't know if I really need to clean up all of that broken material, because that broke early on in its usage but kept working fine. And all of that is basically just relief area. But I don't think I'll bother grinding away all of that damage. What would you do? Would you take all the damage off and then split the carbide further back and basically start from scratch recreating the whole tool, or would you also just leave that shipping as clearance? Right, so to set this up, I'll use a square to get it square to the table. So here I'm aiming for 7 degrees, and I think these are 2.5 degree dashes, so that's 2.5, 5. So that would be 7.5. And when you get 0.5 degree back off it, which let's call it about there. So I didn't have that properly tightened down at the start, and now I've taken more off than expected. So now that tip is thinner than it needs to be. So I will be grinding back that damage. So how'd it come out this time? I'm really not sure if that diamond wheel's any finer than the first one I used. Its surface must be a bit uneven by now, because all that back relief is not terribly even, but as long as it's not going to touch, that shouldn't really matter. You can see from the end of the cutting edge here back to this edge on the back relief that it's back at a diagonal, so that means it must be further back, as is all of this material. So I'm reasonably confident that I've got adequate back relief. Cool, so that's the last of my tools that I need set up. Now I just need to dial them into the tool table on the machine. Oh, this one needs a pull stud. I use two different kinds of tool holders. The ones with the two sort of bits here about the same width are SK40, and then I've got these ones where you've got a thin and a thick bit. Those are BT40, and they need different length pull studs. I think the long pull stud goes on the BT40 and the short pull stud goes on these SKs. I'm going to have to go back through the footage and try and work out what I did wrong there, because I set all of my tools up last night, did all the offsets. That tool came down to the same place as the others. It started the spindle at the same place. Being the fifth tool in the program, I didn't look at the distance to go. That was definitely a mistake. Anyway, I do have a spare nut for that. Not sure how round that collet's going to run, but we'll check that. And the other half of my piece of carbide still looks okay, so I guess I'll grind up a new bit, reset that program and check what the hell went wrong. I sure am disappointed I did that, because otherwise it was coming along nicely. I think there's enough heat build up in there that it's actually hardened the surface a little. Plus I've got carbide down in that hole. If I can't get that out, this piece is going to be scrap or used for something else. So what options would I have to address this? I got very good feedback from Peter at Edge Precision. He of course recommended that for this sort of thing you really want to cut it in one single setup. His suggestions were twofold. On the one hand, I could have held the part in the chuck like this, machined the boss which centers this part into the rotary table, drilled the hole, and then reached through with a long boring bar and put that taper on the back side of the part, all without changing the setup. And then once all that was finished, I could have flipped the part and machined all of these outer features which you can see, which are not critical. They're not alignment features. That's an excellent input and probably quite doable once I've got a boring bar that's this long and this rigid. So that would be one option. The second option would be to simply hold a longer slug of metal than I need, drill it, machine the taper from the front, and then go in and turn all of those rear portions also in that same setup, and at the very end just remove that extra chunk when I turn it over and face it off. Those are both options of how it should have been done. Yeah, the other method of turning this true and correct in the first place would have been first mounting this part, only boring the hole, doing the taper and roughing some, the extra material off, and then making up a mandrel which is sort of a mix of the collet portion with a thread and a nut to grip that piece of steel with centers on each end of it. And you could mount the part onto the mandrel where it's centered perfectly off its shaft and taper. And at that point, you can then do all of the outside machining, including removing and installing the part, without losing accuracy because you're working off centers. Third option for making a new mandrel would simply be turn it, but leave it a little bit oversized, heat treat it, and then take up my friend Luke's offer because he's got a cylindrical grinder and would be willing to grind all those surfaces on the cylindrical grinder. The next thing that was discussed was, well, what could I possibly do about fixing or at least dialing this in each time? It seems most of the problem is probably that I got the clearance between the rotary table bore and the alignment boss a little bit too loose. There were various suggestions such as knurling it to offset the metal and then machining it back down. It's one sort of common old way of doing that. Another way would be plating it back up. A third and quite interesting option was, how about putting a couple of O-ring grooves into the outside of that shaft and then using very fine O-rings that supposedly used quite a bit on modern precision engineering, where basically the rubber provides the centering before you crank the bolts down. So that was quite an interesting method. That would all work, assuming that that bore is actually parallel to the outer diameter, which locates it here. Now, when I machined it, if I got any angular displacement on that shaft, those sorts of methods really aren't going to help it. For that, there were some suggestions such as identifying which would be the high spot and then selectively machining that to bring it into alignment or something like that. Another way of centering it, of course, would be using a setup similar to a set-true chuck. For example, I've got 4 T-slots here, so I could make up 4 little blocks which go in and mount in the T-slots and lock off, which then have 4 screws which push onto the 4 quadrants of this, and that would allow me, once you've dialed it in one time, to be accurately centered. As long as you're only taking this on and off, you could leave those in place and have it align repeatably. I don't really see that being a great solution. To machine up 4 of these blocks is probably more work than just getting an extra slug of steel and machining a whole new centering collet adapter. But hey, the show must go on. So that's the end of the operations on the upper side. So what I'll do is just quickly tap it. Now what I have here is just an old Imco lathe, actually. It's one of those Imcomat lathes, but it makes quite a good sort of tapping stand because there's no return spring on the quill. So hopefully I can use this to get a reasonably square tapping. Alright, well let's hope that's now well enough started that I can finish it off with a normal wrench. Oh wow, that pocket's deeper on the side than I expected. It looks like I've got a Y positioning mistake there. That's supposed to be right flush with this side. I mean, I'll be able to work around that, but shouldn't need to. Now the next thing I need to do is rotate it to put that corner on center height. First up, I'll measure the height here. This is a 25mm bar, so it'll be minus 12.5 millimeters. And that'll be my target center height. Okay, so my target height's going to be around 135.3, 135.4 in that sort of range. 135.3.4. And to get that on center height, I'll just jog the rotary table. Okay, that's looking pretty good, and it comes out at just about 17 degrees. Now to do the last operation, I need this at 180 degrees away from there, so at 197. So I think I'm going to go edit mode, angle 197, point. Better go and read the manual again. Okay, if I've got this right, then I'll reset. Go to manual mode. If I go start. Cool. Right, we're now down to the last toolpath, and the aim of this toolpath is to take this back ear off this here, because that's not necessary. And I'm using a tapered end mill for this to also give a bit of side relief to the insert on the end. See here? We've got to plunge down to minus 210 in Z. That's this here. And it says to go down to Z minus 3.978. The next move is an extremely long move over to minus 270 in X. But here it's go to minus 23 in X. This makes no sense to me. What's a G55? I wonder if that's causing the problem. Let me look up what G55 is. Well, I looked it up, and G55 is Set Coordinate System 2. Now, I have no idea why FeatureCam decided to try and change coordinate system in the middle of this toolpath. But there you go, with it gone, we now have the toolpath. This part I designed ages ago in FeatureCam before I switched over to Onshape. So that's the reason why I'm just still doing this in FeatureCam. I had a very old seat of it. I bought it years ago from a bargain bin. It's a 2005 software, I think, so 20 years old. Very clunky, very Windows 95-y. I'm still working on learning the CAM software package for Onshape. By the way, if you're interested, I'll leave a link below. Onshape's offering a 6-month free trial period of Onshape Pro. Now, another thing I'm going to have to be very careful about here is the CAM software wanted to use the tip of the tool and do all the cuts out here on the thin part. Because all of the cutting is only a side cut, what I've done is told FeatureCam that this tool is 15 millimeters shorter than it really is. So it's going to use this portion of the tool. But I'm just going to have to be very careful, of course, that I'm now sticking down 15 millimeters lower than the CAM software thinks it is. So I blued up the pocket. Yeah, this error must be in my cam setup, where I think I must have used the wrong origin and why. That tip was a 30mm diameter, but I got very focused on the 25mm shank. Maybe I put the centerline 12.5mm from this corner rather than 15mm. That would sort of make sense. Kind of annoying, but because the tip of the tool sticks out beyond the shank, it should still work fine. It looks like 1.5mm I need to take off, which if I had that offset off by 2.5mm, I wonder how I ended up with that number. Okay, that was only a 0.5 mil in diameter, so I'll do another pass. Okay, that looks pretty good. Now before I can use this, I do need to put a flat along here so that these screws don't go straight into the shaft. Right, this job just gets the small and light vise, spacer it up a bit, and there's my bar. I need to set that 17-degree angle. The very last feature I need, when I'm using this tool as a boring bar in the lathe, its alignment feature to put that cutting tool on center height is this 8mm pressed in alignment pin. Now because I'm going to switch between tools, I don't want a permanent pressed in tool, so what I think I'll do is tap a hole for M5. M5's head's a bit oversized, so I can then cut that down on the lathe, and I'll just screw that in when I want to use it on the lathe and remove it when it goes in the boring and facing head. Right, same half-ass tapping rig as before. Not sure if this knurling's going to clean up, but let's give it a go. Oh, it did. Right, well, there we have it. One finished boring tool. Right, for this to be on center height, that point of that should be at 32mm. Yep, I'll call that close enough. Cool. Given I did that with the sketchy magnetic angle gauge, that's probably more luck than skill. Right, well, I guess we better do a test cut and see what the thing cuts like. Well, it didn't like that at all. Instant tip failure. Let's swap that around and try that again. Okay, with proper feeds and speeds set, let's see how that works. Bit of a bird's nest, but this time the insert was not damaged, and that surface finish also doesn't look too awful. Now my guess is I don't really have to take that out unless I need to, because these will clamp down onto the rest of the shaft anyway. So there we have it. I'm pretty happy at how that came out. It's not perfect. I had some issues going through there, but it should hopefully work. Now, one question I do have for you guys is, do you tend to heat treat tools like this? And if so, would you send this out for nitriding, or would you try carburizing it yourself? Because I do have the oven, I do have some carburizing powder, so I guess I could do it myself. Or do you just leave these sort of tools in their soft state? So once again, this week it's a bit of a mixed bag. A bit of disappointment that I didn't get the long boring bar made, and that I crashed the machine. That sucks. But I did get the short one made, so that's at least something. Now, if you enjoyed this video, I suggest that you take a look at the video that pops up here, because it's the one the algorithm thinks is just right for you. Thanks a lot for watching.